In this video, we are going to go over the Triangle Inequality Theorem. The Triangle Inequality Theorem, T37, says the sum of any two side lengths of a triangle is greater than the third side length. Let's look at a picture of this. That AB plus BC is greater than AC, BC plus AC is greater than AB, and AC plus AB is greater than BC. Think about it this way. The shortest distance between 2 points is a line. So between points A and B, it's going to be the line AB. It's not going to be out here to C and then back to B. Let's do an informal proof for this theorem. So we're given triangle ABC, and what I did, I constructed a point X on the line AC such that A is between X and C, and also AX is going to be congruent to AB. Since we have two congruent sides, we know from this that triangle ABX is an isosceles triangle. But first, let's deal with the fact that A is between X and C. Since A is between X and C, we can say that by the segment addition postulate, this length XC is going to be equal to the length AX plus AC. Now let's look at the fact that triangle ABX is an isosceles triangle. Since it's an isosceles triangle, we can say that this angle X is going to be congruent to this angle ABX. And that's by the definition of an isosceles triangle. The sides that are congruent, the opposite angles, are also congruent. Because triangle ABX is isosceles, by the isosceles triangle theorem, angle X is congruent to angle ABX. And since those two angles are congruent, by the definition of congruent angles, they're equal in measure. This angle ABX is part of a bigger angle XBC, and that's by the angle addition postulate. So this angle XBC is equal to the measure of angle ABX plus the measure of angle ABC. Now that we have this equation, we can use the definition of inequality to say that one of these angles on the right is less than the angle that they sum up to be. By the definition of inequality, we can say that the measure of angle ABX is less than the measure of angle XBC. Remember that we said that the measure of angle X was equal to the measure of angle ABX. So let's substitute the measure of angle X in for the measure of angle ABX. So this angle X is less than this angle XBC. But remember the theorem we did in the last video, T36, the theorem that I nicknamed large angle, long side. It says that if two angles of a triangle are not congruent, which these two are not, then the larger angle is opposite the longer side. Since XBC is the larger angle, then side XC is greater than side BC, the side opposite the smaller angle. Hence, BC is less than XC by theorem 36, T36 for short. But remember, when we used the segment addition postulate, we said that XC was equivalent to AX plus AC. So let's substitute AX plus AC in for XC. So by substitution, BC is less than AX plus AC, but remember, AX was congruent to AB. So let's substitute AB in for AX. So since AX is equal to AB, by substitution we can say that BC is less than AB plus AC. And that is what we needed to prove, that the sum of any two side lengths of a triangle is greater than the third side length. AC plus AB is greater than BC. And this isosceles triangle can be formed off of any of these sides, so we can use the same method to show that BC plus AC is greater than AB, or that AC is less than AB plus BC. And that is the proof for the Triangle Inequality Theorem.